Download this code and get free GPT-4o from codegive.com, link in the description below. Sure. The knapsack problem is a classic optimization problem in computer science and mathematics. The dynamic programming approach provides an efficient way to solve it. Let's break down the problem, the dynamic programming solution, and provide a code example. ### problem definition. The 0/1 knapsack problem can be described as follows. You have a set of items, each with a weight and a value. You need to determine the maximum value you can carry in a knapsack of a given capacity. You can either take an item, 1, or leave it, 0, hence the name 0/1. ### dynamic programming approach. The dynamic programming solution builds a table where each entry dpiw represents the maximum value that can be achieved with the first I items and a maximum weight w. Steps *. 1. Create a 2D array dp, where dpiw holds the maximum value that can be attained with the first I items and capacity w. 2. Initialize the first row and column of the table to 0, as no items or capacity would yield a value. 3. Iterate through each item and each capacity, updating the table based on whether to include the item or not. If the weight of the item is less than or equal to the current capacity, check if including the item increases the value. Otherwise, carry forward the value from the previous item. ### example code. Here's a Python implementation of the dynamic programming solution for the 0/1 knapsack problem. ### explanation of the code. 1. Function definition. The knapsack function takes 3 parameters, values, weights, and capacity. 2. dp table initialization. A 2D list dp is created with dimensions, n+1, x, capacity +1, initialized to 0. 3. Filling the dp table. The outer loop iterates through each item. The inner loop iterates through each possible weight from 1 to capacity. The value is determined based on whether the current item can be included or not. For result, the maximum value that can be carried in the knapsack is found in dp and capacity. ### complexity. Time complexity, \o, and times w, where and is the number of items and w is the capacity of the knapsack. Space complexity, \o, and times w, for the dp table. ### conclusion. The dynamic programming approach provides an efficient way to solve the 0/1 knapsack problem. The example above illustrates how to implement this algorithm in Python. You can modify the values, weights, and capacity to test different scenarios.